Today we're going to look at calculations in projectile motion. We're going to separate the horizontal from the vertical and see what they have in common at the same time. Horizontal does not affect vertical. So you'll notice that this looks very similar to the VV.dat table that we used in one-dimensional motion, only now we've added another column because now we're going to put in information for X and for Y. So we're going to fill out a VV.dat table using our assumptions. We're not going to use any information in the X for the Y and nothing in the Y for the X except time. Time is the only thing that that these two columns share, because you can't be in two different places at once, can you? If you have filled out the table as much as possible and can't find the information you need in one direction, you use the other column to find time so you can use it for both. So here are some assumptions made for projectile motion. In the horizontal direction, we're going to assume that there's no acceleration. We're in a perfect physics world where there's no air resistance, and therefore it doesn't cause your object to slow down when you throw it. The initial velocity and final velocity, and all velocities for that matter, in the horizontal direction are always the same. So simply put, initial velocity is going to be equal to final velocity, whatever that initial velocity is. Displacement is usually positive unless it's specified to be in a negative direction. So when it asks how far away or anything like that, that number is usually going to be positive. Now in the vertical direction, we do have an acceleration. As long as we're on Earth, we're assuming that acceleration is negative 9.8 meters per second squared. Velocity is always changing. Why is velocity always changing? Because acceleration is the change in velocity. So if we have an acceleration, that means that velocity is changing. Being on Earth is what allows us to make these assumptions. The only time we would change this acceleration is if the object is on a ramp or on a different planet. But if it's on a ramp, it's probably only moving one direction, and we are doing projectile motion, which is in two directions. When an object is dropped or has a horizontal initial velocity in the y direction is 0. All right. When the object is falling, displacement is negative because your down is a negative direction. And that's the same reason why acceleration is negative 9.8. Anything going downward is considered to be negative. Common phrases in word problems. Neglecting air resistance. This is what allows us to make most of these assumptions anyway. So don't change anything if you see neglecting air resistance in a question. How far from the base of the cliff? Position of release. This is talking about horizontal displacement. How high? This is asking for vertical displacement. How fast? This is asking for velocity. Be sure to check if the question is asking for vertical or horizontal velocity. And we're going to use VV.dat in that direction. So here's an example. This example is on your quiz, so be sure to take notes. Softball player wishes to determine her pitching speed by throwing a ball horizontally from a height of 2 meters above the ground. The ball lands 17.92 meters away. How fast was the ball traveling when it left her hand? So we're going to use a VV.dat table. And the first thing we're going to do is fill out the table. Now we do have some assumptions here, and we'll go through each one of those assumptions. First of all, while we're reading the question, it says that we're throwing the ball horizontally from a height of 2.0 meters above the ground. So what that means is that is displacement in the y direction. Now, although in the question it's a positive 2, you'll see that when we put it in the table, it's negative 2. That is because the ball is falling from her hand to the ground. So the ball starts off 2 meters above the ground, but its displacement will be 2 meters downward. So you put negative 2. The ball lands 17.92 meters away. Again, away means displacement in the x direction. So that's going to be dx. How fast was the ball traveling when it left her hand? The fact that it's asking how fast means it's asking for velocity, and it's asking for horizontal velocity because it says that she threw the ball horizontally. So some other assumptions that we made is that VI is equal to VF in the x direction. The acceleration in the x direction is 0. The acceleration in the y direction is negative 9.8. And the initial velocity in the y direction is 0. Again, that's because she threw the ball horizontally. So if you don't have enough information to get the answer, that what we're looking for is VI or VF in the x direction, pick the column that has the most information. Now this is based on the 4 equations that we use for constant acceleration. And if I try to use this equation, the one I would use would be the one without t, which is down here. But if I try to use that, acceleration is 0, so I get vf squared equals vi squared, and that doesn't bring me anywhere because they're both the same thing. So that means I have to get t in the y direction in order to get what the information I need in the x direction. So we're going to use this equation. This equation allows me to get t, and I know this says delta x, but we're using it for the y direction. So delta x, or you should say displacement in the y direction, is negative 2. Vi in the y direction is 0. We're looking for t, so I just put t there. And then 1/2 times negative 9.8 t squared. Now we're going to solve for t. So we're going to put our math brain on for a second. If I multiply 1/2 and negative 9.8, I get negative 4.9. So what I did was I divided both sides by negative 4.9. And so that's why it looks like that. And then we're left with t squared. And so we square root to get t by itself. So after doing all that math, we get t to be 0.64 seconds. And we put that in our table. That 0.64 seconds is the one that's shared for both the x and y columns. Now we can solve. And we are going to solve using the top equation. That seems to be the simplest one. Now we have delta x equals 1/2 vi plus vf delta t. Now, filling in delta x, we have displacement in the x direction right here. And we put that in as 17.92. And then 1/2 vi plus vf, and then the time that we found, 0.64. Now we have to realize that vi plus vf, since vi and vf are the same thing, will be the same thing as saying 2 vi, because it's the same number time plus the same number. And so 2 times 1/2 is just 1, so we're left with just vi on this side. Now to get rid of the 0.64, since it's multiplying, we're going to do the opposite, which is divide. So we divide both sides by 0.64. to get 17.92 divided by 0.64. Throw that in the calculator, and we get approximately 28.04 meters per second. And you just pick the answer closest to that. All right, guys, good luck on the rest.